Okay, I am just here to record a quick video version of the mini lesson I gave today, and this has to do with the structure of the atom. And it becomes really important for our discussion of electricity to understand how the atom is put together. Um, First thing you need to know about the atom is this phrase. First of all, it's wrong, but it was first brought up by a guy by the name of Democritus. Democritus was an ancient Greek philosopher, natural philosopher, and politician of some sense, because he's the one that came up with the idea of a democracy. Every person in the city-state gets one vote, and all problems are discussed by everybody, and then a vote happens for everything. This is a very impractical way to run government. I've got some friends, and a group of 5 of us will go out to eat. Everybody's got to vote on what restaurant. We can't pick a restaurant. It's just, Plus, everybody has to be an expert on everything. So our representative democracy is arguably a better situation. But what Democritus was talking about here is he was talking about the nature of matter. And he said that matter is made of smaller pieces. So if I have some object, like a hunk of cheese, and I cut the cheese in half, then both halves are cheese. And if I take one of the halves and I cut that in half, why, both halves of that are still cheese. But is there a smallest bit of cheese that either cannot be cut, or if cut is no longer cheese? And he called that the uncuttable. And that's what atom means, the uncuttable. So the idea, without ever even seeing these things, is that that there is an uncuttable smallest chunk of matter, and everything is built up from there. That's the idea, anyway, and it could take on many, many, many different iterations, incarnations. We currently understand the atomic theory of matter as the atoms are the basic building blocks. There are, 116 different kinds of atoms. They're listed on the periodic table in the chemistry class. And you can build molecules out of them, and the molecules can then be either made with other molecules or just a whole bunch of the same molecule. And so they're tiny, little, invisible constituents of matter. They are the Legos from which the universe is built. In fact, there's an old dad joke: is, hey, don't believe atoms; they make up everything. But atoms themselves are not uncuttable. They can be cut, although when you do cut them, you don't get, hold on, I'm going to have a focus issue here, aren't I? That's not it. Oh, dude. There's my focus. Okay, they're not uncuttable. You can cut them, and when you do, you find that they are made up of protons, neutrons, and electrons. Now, since we're talking about a discussion of electricity, I think we need to focus on these guys right here. They obviously have something to do with electricity. Protons have an interesting property. They are positively charged. They have a positive electric activity. And electrons have the opposite electric activity, which we call a negative charge. And neutrons have no electric activity, hence the term neutron. It means neutral. And original model of the atom, it was thought that the atom was just kind of this thing, and it was made up of a bunch of positive charge, and then the electrons were kind of scattered into it. This was called the plum pudding model. Maybe even the protons and neutrons were scattered into. There have to be as many protons as electrons, but we can have as many neutrons as we want. There we go. There's my atom. So we might call this the plum pudding model. Not exactly the plum pudding model of the story of the atom, but the idea that just this stuff is randomly scattered. And experiments were done, and it was found that this is not the case. This is not the case at all. In fact, the protons and neutrons are concentrated into a small area called the nucleus. And so I'll put P for proton and N for neutron, and this is a helium nucleus. Now the electrons would then be going around the outside in kind of a orbital fashion. So this is called the atomic model. Planetary model. Now, the planetary model, it's not exactly right. Nope, there's a little problem here. But before we go any further, let's talk about scale. I don't need you to memorize these numbers, but check this out. On a small atom like a helium, this nucleus is about 10 to the minus 15 meters across. Now, I just need you to notice that that's a very, very small number. These are very, very small things. You can't see these with a microscope. Even a scanning tunneling electron microscope does not give you a clear image of any of this stuff, okay? The size of the orbits of the electrons around a small atom like helium is on the order of 10 to the minus 10 meters. What I do need you to see, other than both of these numbers being very small, is that there's a 5 order of magnitude difference between them. Okay, so let's put this in perspective, and I'll show you why this is such a silly picture. This is a golf ball. A golf ball has a diameter just under 2 inches. That means that its radius, we'll think of its radius as being 1 inch, 1 thumb joint from here to here, okay? And if this represented the nucleus at 10 to the minus 15, we would need to go 10 to the 5 inches in that direction till we got to the electron. And 10 to the 5 inches is about 8,000 some feet, 8,500 feet, which is about 1.5, 1.6 miles. So to put my electrons, and by the way, the electrons would be even smaller than the nucleus, I would have to go 1.5 miles away from my house for this to be a scale model of an atom. So this picture here is silly. It just fits in textbooks, and so people say it. It's also wrong for another very important reason. You see, these electric charges mean that these things exert forces on each other, and a positive and a negative charged object will attract each other. Well, that's how this works. That's how this is like the solar system. The Earth is attracted to the sun in the solar system, but the Earth is moving, and so it winds up orbiting the sun, never crashing in, but always trying to, in a way. But this electron and that electron are both negative, and negative, or positive and positive. These two will repel each other. That means that every time these electrons get anywhere near each other in their orbit, they push on each other and they damage or destroy each other's orbit. They're of approximately the same mass, so it's a shoving match. So the better model is the electron cloud model. That's where our protons and our neutrons still live in the nucleus, and our electrons are still going around the outside, not to scale, but their path is very chaotic. They're all over the place. They may even have an average position, kind of a roughly spherical shape they make, or they might make some weird dumbbell shapes. I've studied that in chemistry class. But this creates an electron cloud. The electron cloud, by the way, is an impenetrable electron cloud. If another atom comes nearby and wants to interact with this atom, it stops when its electrons get to where these electrons are, and these two atoms will interact via their electrons. That's what chemistry is, the interaction of atoms via their electrons. The nuclei will be separated by, well, the diameter, the diameter of an atom. And so the big question is, what's in this space between the 10 to the 5, 10 to the minus 15 nucleus and the 10 to the 10 orbital radius of the electrons? What's in that empty space, that 1.5 miles here in the real world in my golf ball model? And the answer is nothing. There is no thing that is small enough to be in that space. That is truly empty space, and that is the only place in the universe you can find truly empty space. That means that most matter is mostly empty space. Hey, there's one more thing we need to talk about here. We said that the electrons with their negativeness are attracted to the protons with their positiveness, and that the electrons with their same charge, both negative, push each other around and create chaotic orbits. But what about this? What about the nucleus? How do we get two protons that hate each other? They repel each other via this electrical interaction. How do we get them to live happily in a stable nucleus? And we know there are stable nuclei around because, well, matter is stable, at least most of it that we see. And the answer is there must be some other force that is stronger than this electrical repulsion, that when the protons get close enough together, it clamps down and it squeezes them together, and this is called the strong nuclear force. The strong nuclear force holds the nucleus together. It's stronger than the electrical force. It works over very short ranges, and that's why the nucleus is so compact, and that's why bigger nuclei, big, fat, heavy uranium and plutonium nuclei, have a tendency to fall apart. The most stable nucleus is iron, it turns out. there's one more thing. I said this is an impenetrable cloud of electron, and someone once asked me to explain that, and I remembered something from a Eureka video years ago where they said, you know, imagine you give a kid a bunch of yo-yos, and this kid hangs a yo-yo off of these 3 fingers, and on his other hand he hangs a yo-yo off of those 3 fingers. Now he's not going to do the yo-yo thing. He's just going to take his hands and start swinging these yo-yos around his body. Imagine this is the kid, and this is the path of all these crazy yo-yos as he pulls ninja maneuvers and creates a cloud of yo-yo around him. Well, you're not going to be able to attack that kid, because on your way in, you're going to get clocked with 1 or more yo-yos. So by taking individual particles and making them move around in a crazy pattern, you create a cloud, an impenetrable cloud of electrons that shields and protects the nucleus. The nucleus is not involved in chemical interactions. Okay, so what does this have to do with electricity? So electricity is really going to be about keeping track of electrons. And the reason it's the electrons is that they're on the outside of the atom. So if this atom was to be rubbed or molested in some way, you're very likely to knock off electrons. So if an electron leaves this atom, it becomes a positively charged atom. And that electron could go somewhere else and make the thing that it goes to become negatively charged, where there's too many electrons, not enough protons. So let's imagine that we put some atoms together into a molecule, and that molecule is nylon. Now, nylon is a great material, like a plastic. We can spin it into fibers. We can spin those fibers into carpet, and now we have nylon carpet. Why nylon carpet? Well, nylon doesn't get wet, so your carpet won't get wet and mildew and smell funny. Nylon doesn't necessarily hold on to dust and dirt very well, so you can vacuum nylon carpets very well, and they're very strong. Downside is when you rub your socks across the carpet, so here's the nylon carpet, and then here's one of your big fat feet in a cotton sock. When you rub and create friction, you're knocking electrons off. Nylon loves electrons. And so preferentially, the electrons that are knocked off at the interface here will settle into the nylon carpet. That makes the nylon carpet have a negative charge, and your sock will then acquire a positive charge. In fact, your body acquires a positive charge. You are missing some electrons, and so you have a positive charge. Now, if you go and you touch something like a doorknob or a faucet, over here in my house, I got faucets with you know, little things here, and I go and I reach my finger out. I don't know how to draw a finger. And I go to touch the faucet. When I get really close, the metal in the faucet, which contains plenty of electrons and is possibly even connected via plumbing to the earth itself, says, I see you're missing some electrons. Let me provide some to balance you out. And a whole stream of electrons goes into my body in a hurry, and that is a discharge or a spark. That is electricity. Now, all this came about because the ancient Greeks, who were thinking about these atoms as well, also had this interesting thing. They like to make things out of amber. Amber is fossilized tree sap, and amber is very electrically active. In fact, one of the things they like to make is they like to make hair combs. And when women wash their hair, oh, maybe men too, I don't know, I always picture ancient Greeks as being bald. But so when the women would wash their hair and then comb their hair out, once the hair was dry, they found that the comb became electrically charged. You could pick up bits of dust with the comb. You could maybe even throw a spark with the comb, you know, shock somebody with it. So the ancient Greek word for amber was actually electron. So they knew that there was something going on, and that's where the name electron and electricity comes from. So static electricity is based on the structure of the atom, the fact that the electrons get knocked off of atoms. The fact that these electrons carry a negative charge means that macroscopic large objects can become charged either positively or negatively, depending on whether they have too many or too few electrons. And that's a good lesson for today.